Standard split-bolt connectors, often referred to colloquially, should not be used for tapping into a grounding electrode conductor or GEC. The National Electrical Code, or NEC, provides specific requirements for making connections to the GEC to ensure a reliable and safe grounding path. The purpose of the grounding electrode conductor is to provide a low-impedance path to earth, facilitating the clearing of ground faults and ensuring the effective operation of overcurrent protective devices. Using inappropriate connectors can compromise the integrity of this path, increasing the risk of electrical shock and fire. Firstly, standard split-bolt connectors may not provide sufficient contact area for a low-impedance connection, especially when dealing with large grounding electrode conductors. The NEC requires that connections to the grounding electrode conductor be made using methods that ensure a permanent and electrically sound connection. These methods typically involve the use of listed and labeled connectors specifically designed for grounding applications. Secondly, split-bolt connectors are often not suitable for direct burial applications where the grounding electrode conductor is in contact with the earth. The corrosive environment of the soil can degrade the connection over time, leading to increased resistance and a compromised grounding path. Listed grounding connectors are designed to withstand these harsh conditions and maintain a reliable connection. Thirdly, the NEC specifies that connections to the grounding electrode conductor must be accessible for inspection and maintenance. Split-bolt connectors are often difficult to access and inspect, especially when they are buried or located in hard-to-reach areas. Listed grounding connectors typically provide a more accessible and maintainable connection point. Now, let's discuss the approved methods for making connections to the grounding electrode conductor. One common method involves the use of exothermic welding, also known as a cat-weld connection. This process creates a permanent metallurgical bond between the grounding electrode conductor and the grounding electrode, providing a very low impedance connection that is highly resistant to corrosion. Exothermic welding is often used for connecting grounding electrode conductors to ground rods, ground plates, and other grounding electrodes. Another approved method involves the use of listed and labeled grounding connectors. These connectors are specifically designed for grounding applications and are tested to ensure that they meet the requirements of the NEC. They are typically made of copper or bronze and are designed to provide a secure and reliable connection. When selecting a grounding connector, it is important to ensure that it is compatible with the size and type of grounding electrode conductor being used. The connector should also be listed for direct burial applications if it will be in contact with the earth. The NEC also allows the use of irreversible compression connectors for making connections to the grounding electrode conductor. These connectors are installed using a special crimping tool that creates a permanent mechanical and electrical connection. Irreversible compression connectors are often used for connecting grounding electrode conductors to equipment grounding conductors or to other grounding electrode conductors. It is important to follow the manufacturer's instructions when installing these connectors to ensure a proper connection. In addition to using approved connectors, it is also important to follow the NEC requirements for the size and type of grounding electrode conductor. The size of the grounding electrode conductor is determined by the size of the service entrance conductors or the equivalent size for service supplied by a transformer. The NEC provides tables that specify the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The type of grounding electrode conductor is also important. The NEC allows the use of copper, aluminum, or copper-clad aluminum conductors for grounding electrode conductors. However, aluminum conductors must not be used in direct contact with the earth or within 18 inches of the earth. Copper conductors are generally preferred for grounding electrode conductors due to their high conductivity and resistance to corrosion. When installing the grounding electrode conductor, it is important to ensure that it is properly protected from physical damage. The NEC requires that grounding electrode conductors be securely fastened to the building or structure and protected from damage by conduit, armor, or other means. The grounding electrode conductor should also be installed in a manner that minimizes the risk of it being damaged by excavation or other construction activities. Now let's consider some practical examples of how to make connections to the grounding electrode conductor. Suppose you are installing a new electrical service in a building and you need to connect the grounding electrode conductor to a ground rod. You could use an exothermic weld to create a permanent connection between the grounding electrode conductor and the ground rod. Alternatively, you could use a listed grounding connector that is specifically designed for connecting grounding electrode conductors to ground rods. In either case, it is important to follow the manufacturer's instructions and the requirements of the NEC to ensure a proper connection. Suppose you are adding a new subpole to an existing electrical system and you need to connect the equipment grounding conductor of the subpole to the grounding electrode conductor. You could use an irreversible compression connector to create a permanent connection between the equipment grounding conductor and the grounding electrode conductor. Alternatively, you could use a listed grounding connector that is specifically designed for connecting equipment grounding conductors to grounding electrode conductors. Again, it is important to follow the manufacturer's instructions and the requirements of the NEC to ensure a proper connection. The NEC provides specific requirements for the installation of grounding electrode conductors and the methods used to connect them to grounding electrodes. These requirements are designed to ensure a safe and reliable grounding system that protects people and property from electrical hazards. Always consult the latest edition of the NEC and follow the manufacturer's instructions when installing grounding electrode conductors and making connections to grounding electrodes. Failing to adhere to these requirements can result in electrical shock, fire, and other hazards. Remember that the grounding system is a critical component of any electrical system, and it is essential to ensure that it is properly installed and maintained. Using the correct connectors and following the NEC requirements will help to ensure a safe and reliable grounding system. One of the most important things to remember when working with electrical systems is to always de-energize the circuit before making any connections. This will help to prevent electrical shock and other injuries. Always use appropriate personal protective equipment, or PPE, such as gloves and safety glasses, when working with electrical systems. This will help to protect you from electrical hazards. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. Electricians have the training and experience necessary to safely and properly install and maintain electrical systems. Grounding is a critical safety measure in electrical systems. It provides a path for fault current to flow back to the source, allowing overcurrent protection devices to trip and clear the fault. Without proper grounding, fault current can flow through unintended paths such as the human body, causing electrical shock or electrocution. The grounding electrode system is the foundation of the electrical grounding system. It consists of one or more grounding electrodes that are connected to the earth. The grounding electrode system provides a low impedance path to earth, allowing fault current to flow back to the source and trip the overcurrent protection devices. The grounding electrode conductor connects the grounding electrode system to the electrical system. The grounding electrode conductor is typically made of copper and is sized according to the size of the service entrance conductors. The grounding electrode conductor must be securely connected to the grounding electrode system and the electrical system. The equipment grounding conductor provides a path for fault current to flow back to the source from electrical equipment. The equipment grounding conductor is typically made of copper and is sized according to the size of the circuit conductors. The equipment grounding conductor must be securely connected to the electrical equipment and the grounding system. In summary, understanding and adhering to the NEC requirements for grounding electrode conductor connections is paramount for electrical safety. The prohibition of standard split bolt connectors for GEC taps underscores the importance of using listed and labeled connectors specifically designed for grounding applications. Approved methods such as exothermic welding, reversible compression connectors, and listed grounding connectors ensure a permanent, low impedance, and corrosion-resistant connection to the grounding electrode. These connections are essential for providing a reliable path for fault current, enabling overcurrent protection devices to operate effectively and minimizing the risk of electrical shock and fire. Always consult the latest edition of the NEC and follow manufacturer's instructions when installing grounding electrode conductors and making connections to grounding electrodes to ensure a safe and compliant electrical system.